This video will be on a series circuit. We're going to go over some of the rules that deal with a series circuit. And one of the first rules deals with the resistance. And in this series circuit, we have a power supply and 3 resistors in series. The current has to go through one in order to get through the next. And the rule is that the total resistance equals the resistors added up. So total resistance, RT, equals R1 plus R2 plus R3. And as you can see, RT is going to be 10 ohms. Now in this circuit, Ohm's law still applies. So remember Ohm's law from the previous video, and we have this triangle to help us remember Ohm's law. So if we are looking for, let's say, the current in this case, we could cover up the I and see that it equals voltage divided by resistance. So there's another rule with series circuits that deals with the current. And that rule is the current throughout the circuit, the red arrows is the current, right? That is the same throughout. So first of all, in order to figure out the current, we're going to do the Ohm's law. Current equals voltage. That would be the total voltage divided by the total resistance. In this case, it would be 60 volts divided by the 10 ohms equals 6 amps. So the 6 amps comes out of the power supply, goes through R1, then through R2, R3, and back to the power supply. 6 amps all the way. So we could say that I total equals I1 equals I2 equals I3, right? So it's just one current. We call it I. But the point is, when you see this here, it just means that the current is the same all throughout. Same current going through this 2 ohm resistor as there is going through that 6 ohm resistor. Okay, so we know that there's 6 amps going through this circuit. And now we're going to talk about the voltage drops across the circuit. Now we're going to talk about the voltage drops at each component in this circuit. So I'm going to make some room here. We know that RT is 10 ohms, so let's write that over here. RT equals 10 ohms. So we know that we have 6 amps going through the circuit. So how much voltage at each resistor? Well, we'll say that the voltage going through R1, we'll call that V1, right? So that's from this point here to this point over here. We call that V1, right? And this will be V2, and over here will be V3. All right. V1, V1, V2, V3. V1 So our voltage drops will be V1 across the first resistor will be V1, V2 across the second resistor and V3 across the third resistor. And the rule is V total will equal V1 plus V2 plus V3. Well, how much is V1? Well, let's look at Ohm's law. V is current times resistance. So I should do it like this. How much is V1? Well, that's going to be V is current times resistance. So V1 is going to equal the current times R1, which is the 6 amps times the 2 ohms, 12 volts. All right. How about V2? That's going to equal the current, the 6 amps, times R2, which is the 6 ohms, which is going to be 36 volts. And V3 is going to be the 6 amps, right? Is going to be the current times R3. 6 amps times 2 ohms, 12 volts again. Okay. So, V total, 60 volts equals V1, 12 volts. Let's put it up here. 60 volts equals 12 volts plus 36 volts plus 12 volts. Is that true? Yes. 60 volts does equal 12 plus 36 plus 12. So that's the third rule when dealing with series circuits.